Hey everyone, and welcome to this explainer. If you are building or securing digital identity systems, you know exactly what we're up against right now. We are navigating what is easily one of the most complex yet absolutely critical privacy paradoxes of our time. How do we verify humans online without hoarding unnecessary personal data? Look, between deepfakes, autonomous AI agents, and this massive wave of social engineering attacks, simply proving that you're interacting with a real, unique human being is basically the hardest problem in cryptography right now. We need assurance, for sure, but we also desperately demand privacy.
So it all really boils down to this one massive question that's going to anchor our entire discussion today. How do we prove humanness without creating a surveillance state? It perfectly captures the central tension we face every single time we architect a new system. We want a highly trusted system, right? But we absolutely do not want to force our users to dox themselves just to participate in it.
Okay, let's dive right into this. We're going to break this down into 5 key areas: defining proof of humanity, stopping bot manipulation, the centralized doxing problem, zero-knowledge identity verification, and finally, implementing global identity standards.
Section 1. Defining proof of humanity. Let's look at how we actually transition from just relying on cryptographic keys to verifying biological reality. When we're laying out the criteria here, we have to look at insights from industry leaders like Daniela Barbosa and Andrew Hughes. Because when we talk about proof of humanity, we aren't just talking about a basic digital fingerprint. We are talking about establishing a human root of trust. Now, in the digital world, we are incredibly comfortable with a cryptographic root of trust. Private keys, blockchains, all of that. But the human root of trust is the necessary complement. It solves the accountability problem. We need to know what happens when a supposedly trusted actor goes rogue. But the catch? It literally has to be done using privacy-preserving methods. It means you verify a tiny, specific proof of humanity without exposing all that underlying PII. Section 2. Stopping bot manipulation. Let's take those high-level definitions and look at the real-world friction points. Nicholas Kakalis, the founder of the Pi Network, lays out a brilliant framework for this. The core takeaway is that identity verification scales entirely based on its purpose. Not every single transaction needs an invasive data dragnet. Think about it. If someone walks into a physical bank to withdraw cash, yeah, the bank needs exact ID. They need to know exactly who you are. But for most other online systems, you don't need their life story. You just need to know the action is being done by a unique human and not a bot script. System fairness relies on uniqueness, not necessarily on verifying a home address. This comparison perfectly illustrates why uniqueness is the real battleground. On one hand, you have a single bad actor spinning up 1,000 bots. On the other, you have 1,000 actual, verified unique humans. If you are running an online rating system or a review platform and you fail to verify humanness, well, that one guy with a bot farm can completely hijack your entire platform, totally drowning out 1,000 real people. If human verification isn't implemented properly, system fairness is just destroyed. Section 3. The centralized doxing problem. Verifying humans has historically come at a huge cost to the user. Let's talk about the threat landscape of traditional KYC. We are all way too familiar with the KYC illusion. You know the drill: snap a picture of the front of your license, flip it over, snap the back, take an awkward live selfie, and boom, you get that immediate relief of the glowing green checkmark. You're verified. But step back and contrast that feeling with the terrifying reality. Where does that data actually go? The verifying company now holds a permanent copy of highly sensitive ID data, your face, a timestamp, and honestly, there are very few universal rules on how long they keep those audit images. We are essentially creating dark, highly vulnerable, centralized databases just sitting on servers waiting for a breach. To really ground this, Andrew Hughes shared a pretty catastrophic real-world example. The actual French ministry that deals with digital identity and credentials was hacked. Because they were mandated to keep audit images for a set period, those databases became a goldmine, and all those images were stolen. This is exactly what we mean by accidental doxing. Users did everything right. They went through the required process to participate, and because the data wasn't expunged quickly, they got doxed. Centralized audit images inevitably, always, become honeypots.
Section 4. Zero-knowledge identity verification. So how do we actually fix this architecture?
Now, I know what you're thinking. When security experts hear zero knowledge, our minds instantly jump to the highly complex stuff. Advanced polynomial computations, ZK snarks, Starks, bulletproofs. But Nicholas Kokalis makes a really practical point here. Zero knowledge in practice doesn't always require mathematically converting your problem into some massive complex formula. We can actually achieve zero knowledge principles using existing cryptographic primitives and trusted third parties that we already understand. We can prove a statement is true without delivering the raw, unnecessary data.
Let's walk through a classic scenario to see how this builds out. Buying alcohol. In the legacy world, you hand the clerk your physical driver's license. You are literally giving them your exact home address, your exact date of birth, your weight, your full name, just to prove one binary fact, that you are over 21. It's a massive oversharing of data. But let's look at the zero-knowledge approach. Step 1. A trusted KYC authority verifies your full ID just once. Step 2, that authority issues a simple cryptographic signature, a flag that just says, over 21, and ties it to your Face ID data. Step 3, when you're at the store, you present only that signature. The recipient checks the math, verifies it came from the trusted authority, and that's it. You just proved your age without giving a stranger your home address.
Section 5. Implementing global identity standards. Which brings us to the final stage of our funnel. This is not just theoretical whiteboard stuff anymore.
These exact privacy-preserving concepts are already actively deployed in the wild, in high-security environments, through mobile driver's licenses, or MDLs. Andrew Hughes has been doing incredible work directly on these international ISO standards. The MDL standard is being adopted globally right now. Literally, you can see this at TSA checkpoints in airports today. They have successfully built these exact zero-knowledge credential formats right into the standard.
So the crucial point here is the massive shift in data exposure. Think about traditional KYC. You are forced to share your full name, home address, exact date of birth, and driver's license number. But utilizing the ISO MDL standard, you are sharing a simple over 21 cryptographic flag. That is literally all you send over the wire. By using these simple data flags, we are eliminating an enormous amount of unnecessary personal data from the transaction. We are completely starving those dangerous centralized honeypots of the fuel they need to become a liability.
Which leaves me with one final, absolutely vital question for every architect and developer watching this explainer. Are your current identity verification pipelines creating the next massive honeypot? Next time you sit down to design a build, I really challenge you to deeply audit your data storage practices. Ask yourself, are you demanding a full ID when a simple cryptographic flag would do the trick? Because as we've just seen, the tools for zero-knowledge, privacy-preserving verification aren't science fiction. They are here, they are standardized, and they are actively deployed. It's up to us to actually use them.